Okay, we're done with mass of water in the air. We're going to talk about the theoretical oxygen and excess oxygen, which is very simple actually. Many times there is an excess of oxygen to avoid incomplete combustion. Because normally, yeah, if you have, I don't know, this, let's say it's a fuel, you want to cover it a lot from oxygen so it will not form incomplete combustion. So the more oxygen you put, I think they try to react easier, they have more exposure to oxygen, so they react better. So imagine this, we have methane and we have 4 moles of O2 and they will be producing 1 mole of CO2 and 2 moles of water. But the problem here is the methane could also react with 3 half of O2, which will give you 1 mole of CO. And that's not good because we can still oxidize more of this and probably we will have more energy or heat. So if we use excess, imagine we use, instead of 4 we add 5 moles, we will probably not form CO because we have excess of oxygen, and you will form a nice CO2 and water combination. So theoretical oxygen, it's the oxygen needed to perform a 100% combustion. Nice, easy. For example, in methane we need 4 moles of O2 and we need only 2. Let's do the mass balance. This is 1, hydrogen, you need only 2. Oh yeah, no, it's okay. Yeah, we need 4. So the theoretic oxygen is 4 moles of O2 to combust 1 mole of methane. Now, the excess oxygen is the oxygen that does not react after a 100% combustion, and it's always over. You'll have extra. So what happens when we add not 4 moles but 5 moles of oxygen? You will be having also, I don't put it here because it's not that chemically correct, but you have 1 mole here left. So we use 4 moles for the combustion and we have 1 mole that did not react. The excess oxygen is 1 mole. Now we want to change these to percent, so it's easy. Excess oxygen, as I told you before, the oxygen you feed minus the oxygen you actually need divided by the oxygen you need. So for example, for a 20% oxygen excess in methane reaction will be 20% excess. You have these and these and these. So let's just find it, how much oxygen it will be. And you will find out that you want a 20% extra oxygen, you will get 4.8 moles of O2 instead of only 4 moles. So I hope you're getting the idea of what is excess of oxygen, because we're going to talk now about the excess of air. Since we use air to get oxygen to the reaction, we need to calculate air flows from oxygen. So you know 1 mole of O2 will give you certain moles, I think 4.3 mole of air in general. No. Anyways, there's a relationship. We're going to see it later. Theoretical air is the air needed to get the theoretical oxygen that we need. So we first need to check out how much oxygen moles do we need, and with that we can calculate how much air do we need. But this is theoretical. Now the excess air is the air that goes extra, easier. It's almost the same as oxygen, but now it's air. And this will give us higher rates of combustion. And as seen before, it's similar to O2, because percent excess of air, it's the moles you feed of air minus the moles you must actually react divided by the moles of the same mole. This is the same quantity. Just be sure to have the same quantity. Times 100%, of course. Be aware of nitrogen content in air. Don't just add up oxygen. You need to add up nitrogen also, because nitrogen is 3.76 times the quantity of O2, so you will have a difference.